Hello and welcome. In this tutorial we are going to talk about how to create a Python script to split a dataset organizing folders. Let's create a new scientific project. Okay, and let's configure the interpreter for Python. In this case I'm going to use a configured Anaconda environment, and let's call this train valid dataset split. Okay, and finally dataset create. I kind of like to use PyCharm for this kind of design of a script programs. It is very helpful in scientific mode. The project has been started. Okay, we're going to think that this project is something like part of a bigger project, right? So we're going to create a new file where we're going to work. This means that the that py is going to be reserved for maybe for the machine learning classifier or something additional, right? Okay, Python file. We're going to call this dataset splits. First, we should organize our work in the script, and I recommend that you make it in the following ways. First, some descriptions about the program. Organize data in print and validation folders. Next, we should have our import libraries. Notice that in scientific you can create this separation and by sections. Mostly the libraries that are going to be used are OS, random, argparse in order to create command options, shooting, path_lib to create paths and folders, and t2dn to report the progress, right? Next, we can declare functions that are going to be used in a modular way for the program. These functions are going to be a create folder function that receives the new path, the data class or category we're going to work with. This data class is going to be the categories we're going to work with, and the folder type, this means validation or training. Once you create it, it's good that you write what this function is for. Data class, these are the categories. In the folder type, we have for training or validation. If you don't want to write a function yet, you can pass. This program really suggesting more space. Okay. It's important that the original folder containing all our image dataset is organized as follows: dataset, and inside dataset you will have category 1 and its images, category 2 and its images, category 3 and its images, and so on. Okay, until category 10 and its images, right? And what we're going to create is a new dataset split where we're going to have train, and inside train we're going to have category 1 and its contents, category 2, and so on, and validation with the same categories 1, 2, and this is the output that we want. So we are going to reorganize the information that we have. The create folder function is very easy. We need to establish the root, which will get this command, and the target where we are going to save our organized datasets. Okay. And we are going to create function allows me to create the folders if they do not exist, and if they do exist, they are not created again. We are going to return the final path. So what we return here is the final path to category. And this could be, for instance, something like dataset split, train, and here category X, and also dataset split valid category X. Next, we need a function to split data. Is going to be called a split data function. Its arguments are source path, which means where the original images are located, train path, where the train images are going to be located, the validation path, it's for where the tested images are going to be stored, and the split size. Saying we declare something about the function and what it does. So it uses the original data set location and the new train and validation locations, and split size to relocate images in the desired organized output. Now, in the dataset split string category X and dataset split valid category X. One thing important is that the split size is going to be a number between. It's going to be a number, decimal value that splits in train validation. For instance, that 7 would mean that 70% of images are going to be used for train, and 30% of images are going to be stored as validation. So first we're going to create an array to store all images of all original data. Okay, that if the size of the file is lower than 0, that means that the file is empty, we are not going to append it. We're going to append only files that do have space in memory that exist. we can report here zero and so here we report what the problem was. Next, we are going to define the size of, we can make it here, defining the size of training and validation code. Is going to be called training length. I'm going to return an value. Here you see that all the length files is returning me the number of files in the original dataset. I'm going to multiply this by the split size. Similarly, this is going to be length files. We subtract the training length to get the remaining number of files. Now we have to create a shuffle. For this we're going to use random sample. And the amount is all the files. With this, we create a training set that's going to be shuffled set of this size 0 to training length and validation set is going to be shuffle set validation length. So we have assigned the files into two folders, the training and the validation set according to their sizes. For instance, this could mean 70% of training, and this could mean 30% for validation, right? Two spaces. Okay, this is another strong use of Python. It recommends styling while you are writing your program, so that's kind of cool because you can write according to the normatives that are established for Python programs, and then you have a script that is richer than writing it without any help. Okay, next we have to move the files to their destinations. In fact, we can also add, if you may desire, you can initialize this function with a value. For instance, this would mean that by default, if you do not specify a value for the split size, that setting is going to be used. We're going to add it this way. In the next video, we are going to add some additional steps in order to move the files from each category to the destiny directory. So please keep watching the next video so that you can complete writing this program. Thanks for watching.